Hello everyone. In this video I want to cover NumPy indexing. Let's jump right in. Starting out in our text editor, the first thing we need to do is to import NumPy. We'll import it as np just so we can use it easier in our script. Now let's go ahead and create a couple list variables. We'll say ListA is equal to 0 through 10. Then we'll say ListB is equal to 11 through 21. Now we'll go ahead and create an array value using ListA. We'll do this the same way that we did in the last video. We'll create a new variable. We'll say a, type in np.array, pass in the object that we want to make an array out of, and then we'll specify the dtype. For this one, we'll say integer 32, since we're dealing with integer values. Next, we'll print a to the terminal. Opening up a command prompt on our terminal, we'll type in Python 3, and then the name of the file, numpy indexing.py. We see that we get an array object with values 0 through 10. Indexing, just like how it is in Python, is the ability to use square brackets to pull out elements. We'll drop down a few lines and specify the object that we want to pull elements out of. We'll pull elements out of the variable a by using square brackets, and then we can index by passing in numbers into these square brackets. Indexing in NumPy is the same how it is in Python. First, we specify a starting position. Next, we can specify the stopping position, and lastly, we specify a step size if we want to have one. I'll go ahead and comment this out and use it as a reference. Specifying a again, let's start by pulling out the first element in the array. The first element is specified by the 0 index position. So we'll say 0, and then let's index out half of our array. So let's stop at the number 5. To stop at the number 5, we need to include the index position of the element right after it. The element 5 is in the 0, 1, 2, 3, 4, 5th position. So we need to specify 6 here. Then we can include a step size. We'll just say 1 for now. We'll print this to the terminal, and we should pull out every value from 0 to 5, which we do. If we change the step size to 2, we should pull out every other value. Now, instead of pulling out 0 through 5, we pull out 0, 2, and 4. We're also able to negative index. Here, if we change this to -1, we should pull out the last value in the array. When we execute it, we pull out 10. If we wanted to return the entire array just in reverse, we could specify the -1, put in a colon, and then the same way in Python where you don't have to explicitly use another number, we can just skip that step and put another colon. Now we just need to specify the step size, so we can say -1. -1 as a step size is essentially counting backwards. When we save this and execute it, we get the entire array just in reverse. If you don't remember how this works, if either the start or the stop are omitted, they take an end value of whatever you're indexing. Which end of whatever you're trying to index just depends on the sign of your step. If we were to change this from a -1 to a 1 and save it and execute it again, now we just get the value of 10. That's just because our step has a positive sign, so it looks at this end of our array. In the same way, we don't have to state the starting value either. We can execute this and we should return everything in our array, which we do. By default, since this is positive, this value starts at this end of our array. Now let's create a two-dimensional NumPy array. We'll create a new variable called ListC, which will be a nested list including ListA and then ListB. We'll create the array AB by saying AB is equal to np.array, pass in the object of ListC, and then dtype will equal np.int32. We'll drop down a line and print AB to make sure that we've read it incorrectly, and then execute the terminal script again. Now we have a two-dimensional array. We can check the shape by typing in .shape on the array, and we see that we have an array of the shape 2 and 11. Now if we wanted to index a specific value out of this 2D array, we would need to pass in index values for both of these shapes. That just means that we need to specify either 0 or 1 here, and then 0 through 10 for this one. If we don't index down to the same number of dimensions that we have, then we will get an array as our return. Let's see that now. We'll print AB, and then we'll only pass in one index value for a two-dimensional array. We'll say 0. Now when we execute this, we get the array 0 through 10. If we were to change this to a 1, we get the array 11 through 21. So the first indexing number that we're passing to this array is only looking at this. 2 here is just the row. 11 can be thought of as the column. So now let's say that we wanted to pull out the number 13 from this array. We've already pulled out the row that we want. Now we just need to pull out the column. So 13 is in the 0, 1, 2 position. Here we can just type 2. Once we execute, we get 13. However, this isn't the fastest way to do this, because like we saw, this creates a temporary array that we then index again. So instead, you should get rid of these 2 brackets and then put a comma. When we execute, we get the same thing as before, 13. With two-dimensional arrays, we're also able to slice the same way that we were doing before. So here, if we wanted to pull out 13 and 14, we could pass in 4 and then a step size of 1. Executing this, we should be returned 13 and 14. We're also able to use other NumPy NumPy arrays to index a separate array. Let's use our array that we created from ListA. This one was called A, and then let's use a NumPy array and pass in the values 0. This should pull out the first element from our array A. We'll execute and we get the value of 0, which was the first number in our array A. Since we're indexing it with another array, we can pass in as many values as we want as long as it's in the length of this array. We'll save and execute, and we see that we get a new array of the values that we index using this new array. And that's pretty much it for this video. NumPy indexing is very similar to Python indexing, so if you already have a good handle on that, this shouldn't be a challenge. If you have any questions or comments, please let me know. Until next time.